Welcome back to my workshop. This is the first video I've probably done in close to a year. And the reason I'm doing it is because a gentleman I work with found this old Zenith down in his father's basement, and it actually belonged to his grandfather. So this is Zenith Z33J. They manufactured from 52 to 56. They had a different number up front, whether it was Z or R or something like that. But model number was made in 1952-53. No idea if it works. He didn't want to plug it in, which was wise, so I tell him I would take a look at it. Another reason not wanting to plug this in is because of things like this. Right? The power cord is all off. An interesting thing about this particular model, and I think Zenith in general, of AM/FM radios at the time, were that the antenna was hooked up to the power cord. Now it's not physically hooked up, it's still isolated, but this was for better AM reception, apparently. I'm sorry, FM reception. I've never worked on FM radio before, and I should have said this is an AM/FM radio. So we're going to take it apart, see what we can do, and hopefully we'll get it to work. As I said, I've never done an FM radio before, so my plan is not to do anything special with it as far as the FM side, but I will try and restore the AM side. It's also a clock radio. I'm not going to mess with that either. So let's start taking it apart and see what we have here. Take off the knobs. This one's going to give me some trouble. See if I can get this under there. I don't want to break anything. Because it's not my radio, I'm very hesitant about putting too much strength on this. All right, I'm not going to have this being recorded while you're bored watching me do this, so I'll stop at this point. I'll be right back. I'm back. I finally got it off. Took an extra 5 minutes. Thankfully, I didn't do any damage to the knob. I did ruin one of my alligator clips, however, but that's okay. I have tons of those. Let's continue taking it apart. Undo the back. That holds the back panel on. Okay, and now we'll go to the bottom to take out the two main screws. The back of the radio has the diagram of all the tubes, but it also has instructions on how it operates. Because it's a clock radio, it is a little different. I think it's in the always on position because the clock is always running. And if you want to use the radio, you kind of have to switch it off. It also has a very interesting feature, considering the timing of from the early 50s, that you can plug something else in the back. There's an outlet. So I guess in theory, if you have some electronic device like a coffee pot, if they even had electric coffee pots back then, you can plug it in and use a timer for that. All right, looks like all is out. Let's see. This comes out easily. Since this power cord is bad, I'm gonna cut it to avoid it getting in the way. But I'll save it because you're supposed to save the antenna for the FM reception, and I have to look into that at a later date. I think I forgot to take these knobs off from the little clock because that has to slide out too. Checking for other items that could possibly cause this not coming out smoothly. Doesn't seem to be anything. Or is it just that? There we go. Okay, got the back off. And what this is plugged into is something in there that stopped it from coming out. Having a little trouble with this piece. As I'm looking down in the clock, I see there's some screws that are holding the clock in. Let me take those out. There's one. Actually, the clock is not holding in. The clock is totally separate, so I'm incorrect. There is something holding it back still, though. Oh, I'm such an idiot. It's the main dial, of course. There we go. And I think the speaker is still connected. So I have to undo that. These are just pull wires, so that's not an issue. And what else is left? There's a light here to let you know, I guess, when AM, FM is on, or maybe even power. I have to read the schematic. There we go. And that's just a plug as well. So there is the radio in all its glory. Let me turn it a little so you can see it better. All right. So that's the bulb. These two are the speaker wires. I'm just trying to see some other things. It's a 7 tube, I believe. 1, 2, 3, 4, 5, 6, 7. This is really tight, this thing. Wow, can't even turn it. Well, can hardly turn it by hand. This definitely needs a little 10 to 11 care in oil, but that's something we'll look at later. Looks clean, dusty, but you know, what do you expect for a 60-plus-year-old radio? Okay, next I'm going to take the bottom off. This is nice. Zenith was a good quality radio, and you can see they didn't expose the bottom of the radio to any kind of elements like a lot of radios. So it's probably going to be very clean inside, maybe a little dust. So let me take the bottom plate off. These are just hex nuts as well. That's 3, and looks like we have 3 more in the front, so we'll just do those as well. By the way, if you notice down here, there's an antenna. That's the AM antenna, and the one that's attached to a power cord is an FM antenna. Okay. Moment of truth. Let's take a good look here. Very clean. Very clean. Really interesting, this switch. It's kind of like a spring on it. I've never seen anything like that. So my plan is just to replace the electrolytic capacitors, replace the paper capacitors. I'm going to leave these ceramic ones alone. And if I have to replace those, I'll do those as well, but generally they don't go bad. Also, generally the resistors don't go bad. One thing I've read is that this selenium rectifier here, that converts the AC power to DC, and they tend to go bad. And the way you can tell they go bad is that they stink. They smell like rotten eggs or sulfur. So we'll see what that happens. So what are we looking at here? 1, 2, 3, 4, 5, 6, 7. Looks like about 7 wax capacitors. And of course, I also have to replace the electrolytic, which is this guy right here. And once I look at the schematic, I'll see what it should be. Usually it's about something like a 20-20-20. I think it's a 3-parter. So, all right. I'm going to set myself up now to start the soldering. I'll be back shortly. Okay, welcome back. It is capacitor replacement day. So what I'm going to do first is going to compare the capacitors in the chassis to the part list on the screen. And also I have a Sam's Photo Fat copy to that. I have it upside down because it faces me this way and it's angled better for me to work on it. So I just have to read the numbers upside down. So the first thing I'm looking at here is C16. C16 is 0.05. This one here. And it is this one here, which does say 0.05. So I'll start to replace them one by one after I check them, and I'll get back to you in a little while. Okay, I took out the first one from here. Here is the paper capacitor, wax capacitor, 0.05. And in today's world, they don't really make 0.05 especially. So you get 0.047, which is fine. These are not highly sensitive electronic components that require super measurements. It could be off a tiny bit. So I'm going to replace this here. I like to use what they call a J-hook. So I take this, and I take this, and I make a little hook on them. And I just try and get a little measurement there so I can cut it. There we go in front of that one. And actually, let me do it this way because I do like to be able to see the component should somebody ever have to work on it again. Tighten them together. Now I will get my solder. Heat it up a little bit. So joint looks good. And now I will cut some of this off because I don't need all of it. Actually, I could do a little more even. And I'll J-hook this one over here. I'm going to cut a little more. It's still a bit too long. Whoops, sorry about that. Almost knocked the tripod over. And there we go. That's 1 of 7. I'll do the rest off camera because it's boring if you watch the same thing over and over again. Then I'll show you the finished results. I'll be back. One thing I wanted to mention is that when I replace these, let's see if I can get this in focus. This is a .004. Focus, come on. Yeah, good enough. You can see this black band on here. This is called the outside foil, and it's supposedly supposed to protect interference from the signal. New capacitors don't have that, or I should say they're not marked as such. So if you buy some cheap brands, they may not have it. I tend to spend a little extra couple, extra cup 50 cents or more for a piece, and you actually get a good quality one. And generally the outside foil is written this way. So this side is the outside foil, and I would install it this way because this is the way it was taken out. Notice the size difference too. Same protection, same capacitor. All right, I'll be back. Okay, welcome back. It's about 45 minutes after we completed the first exercise of replacing all the paper capacitors, and you can see all the yellow ones here. There are 7 of them, and here's the old ones. I used to collect these and take the wax off and use the sleeves so it would look more authentic by putting the newer components inside these old sleeves. But I probably had, I don't know how many hundreds and hundreds of, and never did it. And to me, it's always easier. You can see how much smaller the components are nowadays than to try and fit them back in and put them back in. This chassis actually has a lot of room to work in, but there are many chassis that you have an issue where everything's tight. So now if I had a really, really expensive rare radio, I'd consider doing something like that. But for this, probably not. So the sound you're about to hear are these wax capacitors going in the garbage. Next thing I'm going to do is I'm going to check all the resistors to make sure they're still in tolerance. Generally, there's allowed to be a certain tolerance level, plus or minus 10%, depending on what the multiplier is on a resistor. So I'm going to measure just 1 or 2 here to show you what I do, and I'll look at them all. And if anything is out of resistance, I'll replace it with the newer component. Generally, for a radio in the 50s, I'm probably not going to have to replace any, but it's always a good thing to check. So I'll look at the first one. This first one here is brown, green, yellow, silver. And looking at a calculator I have here, that translates to 150K of ohm resistance with a tolerance of 10%, meaning it could be up to 165 or as low as 135. So hopefully you can see on the top left, you can see oh, I'm touching something else there, sorry. Try and do it without getting my, okay, 147.9, almost 148, should be 150, so we're well within tolerance on that one. I'll look at another one here. This one here is yellow, pink, yellow. So I'm going to look at this calculator here I have online, yellow. Now color's off, there is no pink, so I'm going to assume it's violet, and that should be 470K. 442K. So that's within tolerance, so that one's fine too. Let me check one more. This one over here is yellow, violet, green. And that should be 4.7 meg ohms. Now, sometimes you may not get what you're expecting. This is 4.2 meg, 4.7. I'll have to measure a little more again because I think that may be a little out of tolerance. But I'll go through all of them. You could get the idea of what I'm trying to do. I replace them with the newer components. Once I go through that, I'll come back. After that, the next step's going to be the electrolytic capacitor. Right now, that's this guy right here. It's a three-parter, 3 components within there. I'm actually not going to, again, if I had a real fancy set, I'd take this out, stuff them inside. But what I'll just do, and what I do with most of my radios, as they're not super fancy, is cut out all the connections here and put the new electrolytic capacitors right on the board. And you'll see when I get to that, I'll show you. So we'll be back after our next step. Stay tuned. Okay, I'm back. So I did have to replace 2 of the resistors right here, which is one of the ones I think I mentioned before, and another one back there that was out of tolerance. Everything else seems to be pretty good with it. My next step is to replace the electrolytic capacitors. I mentioned I'm not going to take apart the can, but these are the entry points here. So I've mounted this little, I don't even know what they call them anymore, but I've mounted this little part to the chassis. There's a hole there already, I didn't have to drill anything. And I'll put the electrolytic capacitors up there and take all the wires that are currently pointing to here, point to there. They'll share a single ground, and the ground will go back to the can, which is already mounted to the chassis. So I will do that, and I'll show you the end results. Okay, I'm back. You can see I added this piece up here. These are the 3 electrolytic capacitors. I disconnected the wires from here and attached them up here. And they all have a common ground, which is this wire I added. And that goes back to the ground, chassis ground on the electrolytic capacitor. So at this point, all the electronic restoration anticipated is done. My next step is to test the tubes to make sure that they're all fine. I'll record that in a little while. And then I have to hook up the new power cord, and we can actually give it a try and run it. Stay tuned. Okay, I'm back. I have the tube tester set up. I'm going to test all 6 tubes. First one is going to be 6BJ6. Actually, what I like to do is this little gadget that kind of straightens the pins out, because these pins can get very bent up. So I just use this kind of to straighten the pins out. Good. So I look at the chart here. I look at 6BJ6. And I just follow the instructions on there. So I have to set different settings. You can see across the top A, B, C, U, D. A, B, C is here. A is the circuit. So 6BJ6 is circuit 4, which it's on already. B is the filament. My assumption is going to be 6, so I'm right, 6.3. It's a 6.3 tube, that's why it says 6. C is the load that you put on it. This is set for 57, so I move it up to 57. Up and down, let's see, 6BJ6. Up is 5 and 6. That's the D set. And then down is 3. I turn it on. I can see the light coming on here. Tube test good. Let's see, 1, 2, 3. Short test. Up here it says a 4. That means if there's a short, when I hit 4, I should see that light up. I don't know if you could even tell it on the camera, but so that's good. And then 6 is for, I hit that down, and that's supposed to be for the gassiness test. That seems to be good. Turn it off. And I'm going to go through this with all tubes to make sure they're okay. And you don't have to watch this part because it's boring. So hopefully all the tubes will be okay. And then we can move on to the next step, which is attaching the power cord. Okay, we're back. All the tubes tested fine. I'm going to do a test run right now. I took the speaker out of the cabinet. Looks like it has a little hole in it, but I can glue that up. That's not a problem. I didn't want to put it back in the cabinet because it has some sort of special connection that I have to figure out what to do. So I basically have wires going to the input here, and then to a regular electric cord, into my Variac over here. I guess I can turn it over a little bit. And then I have an isolation transformer. My phone shut off for some reason. Sorry about that. So I'm going to put this all the way down. On the right, I'm putting the Variac down. I'm turning on the isolation transformer. I'm turning on the power to the Variac. And I'm going to slowly bring it up. I'm actually going to shut some lights off just to see if we get power. I'll bring it up to 40 first. We have 45 volts right now. I do not see any lights yet. I would also expect to see this light up as well, as long as the bulb is good. I'm going to move it up to 60. I definitely would have expected lights by now. $85 volts. Nothing, no sound. I'm at 115, 118 right now, which is the max I put this at. And you do not see anything on. So I'm not quite sure what's wrong. All right, I'm going to have to take a look at it again. Maybe there's some sort of special component where it has to be in the cabinet, but we'll take a look. Okay, I'm back. I was looking at the instructions. Apparently there's a switch to turn the radio on. I could have had it on clock only. So we're going to try it again. Turn it on. Let me put the lights off to see if we see any power yet out of the tubes. Put the volume all the way up. Have it up to 80 volts. I'm still not seeing any lights. I'm switching between radio and clock, so something's still wrong. Okay, I'm gonna have to figure it out still. I'll be back. Okay, I hooked up a regular power cord. It's in the back of the chassis. Plugged it in. I'm still not getting any power. I don't see any lights, so I'm gonna have to take the multimeter and see where the power is or where it isn't. So, yeah, I think I'm going to call it a day because I've been working on this for about about 4 hours. So it's, I think I need to rest my brain and think about what else could be wrong. So stay tuned and we'll bring you the next installment soon.